What are some strategies we can use to help us deal with combined graphs? So one of them we can do is check the domain and range of the function. So the domain and restrictions on the functions that will help us understand what this new function is going to look like. We can calculate coordinates based on how we combine the f of x and g of x. And another thing that we can do is we can combine algebraically and see if we end up with familiar functions. So that's another strategy we can come up with. So for example, if I have f as a linear function and g is a linear function, if I multiply f times g, I end up with a familiar function. This is a quadratic function. Okay, so we can see if we can, when we do the combination algebraically, if we come up with something that is familiar. So example here would be f and g. So I have f as a quadratic and g is a linear function. So when I first of all do the domain and range, the domain is going to be all real numbers here. Okay, the range is going to be based on the vertex. So the vertex looks like it's going to be at -1. So, and I found that using Vieta's formula. So -1, that becomes positive, negative. So the range is going to be y. Looks like the vertex is at -16. Okay, here the domain and range are going to be all real values, all real numbers for the domain, and all real numbers for the range. Okay, now when we combine these, we're going to end up with a rational function that we have already dealt with. So we kind of know how to draw these graphs. So this is just really a rational function where we have a quadratic on top, a linear function on the bottom. Now we have to observe there's a new domain restriction here. Okay, so although these are all real values, the domain restriction, now that we have a denominator, we have to observe that we cannot divide by 0. And when we do the range, again, the range is going to be a little bit more complicated. But if we understand what this function turns into, this is actually a rational function. We would maybe expect an asymptote or a whole at x equals 3. When we factor, we end up with common factors in the numerator and denominator. So that means these cancel out. So we have a whole. So the range is going to be just a linear function with all real values, but x cannot be equal to 3. That means that y cannot be equal to, when I plug 3 into here, y can't be equal to 8. So I have a whole at 3 and 8. So this rational function really just becomes a linear function of x plus 5. So you have a linear function that's just a straight line function, and we have a whole at x equals 3, y equals 8. So it's just going to be a straight line like that, okay, with a whole at that point. So by combining these functions and analyzing the combined function, we can see that this is actually a familiar function, one that we've already seen before.